Look closely at the back of an arm, thigh, or buttocks of much of the global population, and you'll find this exact landscape. Dermatologists classify these distinct, symmetrical, rigid little bumps as keratotic papules. They group together almost exclusively along the extensor surfaces of the body. It is easy to assume this is a superficial skin texture issue, perhaps a response to environmental dryness or a reaction to a topical product. But these papules are actually the final, visible manifestation of a barrier integrity failure occurring deep within the skin's layers. To understand exactly what keratosis pilaris is, we have to look past the bump itself, track the condition down to a single genetic error, and follow the resulting biochemical cascade back to the surface. Diagnosing and properly managing this condition requires us to shift our focus from the visible symptom to the invisible molecular architecture of the epidermis. This diagram shows a standard cross-section of human skin. We have the outermost epidermal layer, the dermal-epidermal junction, and the deeper dermal layer beneath it. The epidermis serves two vital functions. It acts as the body's primary moisture sealant and its outermost structural shield. In a patient with keratosis pilaris, an inherited genetic error, specifically a loss-of-function mutation, destabilizes this exact layer. The error strikes a targeted area, disabling the code responsible for producing a normal, healthy version of a protein labeled here as FLG. Filaggrin is a multifunctional structural protein, acting as a primary component for epidermal integrity. Without it, the structural foundation of the skin barrier is compromised. This single molecular failure acts as the initial domino, leading to a cascading collapse of the localized skin barrier. This flowchart tracks how that failure develops. The loss-of-function mutation in filaggrin triggers two parallel, simultaneous failures. We'll trace the right-hand pathway first, which represents a biochemical breakdown. Filaggrin normally breaks down into amino acids that retain water. The mutation inhibits this, stripping the skin's moisture. As a result, skin pH rises above its healthy 5.5 baseline. Simultaneously, the chart's left side maps a structural failure involving keratin. Without functional filaggrin to organize it, keratin cannot aggregate correctly. It fails to align intermediate filaments inside the skin's dead outer cells, or corneocytes. The combination of these two pathways, a depleted moisture barrier and a breakdown in cellular alignment, creates an environment primed for mechanical obstruction. To see that obstruction form, we must zoom in from the broad epidermis and focus on the microenvironment of a single hair follicle. Because the unaggregated keratin cannot be processed normally, it begins to accumulate within the follicular spaces. This causes hyperkeratinization, a localized overproduction and hardening of the cells lining the follicular epithelium. This mass specifically forms in the infundibulum, the funnel-shaped upper cavity of the hair follicle. Over time, the loose keratin solidifies to form a dense keratinous plug that seals off the top of the follicle. The sheer volume of this solid plug exerts outward pressure, physically widening and distending the opening of the follicle. By forcing the walls outward, the plug creates a significantly larger internal surface area deep inside the follicle. This widened, irregular pocket gives the hair root at the base too much room to maneuver as it attempts to grow. Instead of a single straight shaft, the expanded space allows for the growth of multiple, misdirected hairs that remain trapped beneath the plug. The microscopic genetic failure has now manifested as a localized mechanical blockage, creating a physical barrier for the growing hair. The trapped hair continues its relentless growth, physically pressing outward against the structural cellular walls of the follicle. Under the pressure of the sealed environment, these hairs develop into thick, tightly coiled structures. Every millimeter of growth forces those coils tighter, generating escalating physical irritation against the follicular epithelium. Eventually, the tension leads to the physical rupture of the follicular epithelium as the hair shaft breaches the cellular wall. The moment that tissue is breached, the surrounding cells release chemical signaling markers, known as inflammatory cytokines. This sudden influx of cytokines triggers a localized inflammatory cascade. The immune response draws fluid into the area, causing the surrounding tissue to expand into an edematous state. This immunological reaction to physical trauma is what transforms a microscopic anomaly into the pathological lesion seen on the skin. By looking at these grouped keratotic follicular papules, we can now map the internal trauma directly back to the visible surface. The red, swollen zones tightly encircling every affected follicle are the key clinical indicators. This is perifollicular edema, the macroscopic result of the internal swelling caused by the inflammatory cascade. The rigid bump in the center of that redness is the keratin plug itself, protruding through the distended follicle. The entire timeline is now clear. A filaggrin defect creates dual failures that lead to a keratin plug, which traps growing hair until a rupture triggers localized edema. Keratosis pilaris is a causal inflammatory response to a precise mechanical failure, which explains why these papules emerge wherever filaggrin deficiency meets the anatomy of the hair follicle.